Hello students. So students, in the previous class, that is in the chapter that is this matter around just pure, we were talking about that of the solution, that of the mixture and the compound. We have discussed the properties of the mixture and the compound, and we have seen that how mixture is different from that of the compound. In this one, students, what we have seen here, that basically mixtures, they are having a kind of a property. It means if we talk about the property, if we differentiate between these two, so we have seen that the mixtures, they can be separated through physical means, but compound do not. They are always having a variable composition, but the compounds, they always combine together in a fixed ratio by mass. If we look at the that of the mixture, so mixture, you can say that it is a can be homogeneous or heterogeneous, but in case of a compound, it is always a homogeneous mixture. Means you cannot see any kind of a visible boundary in case of the compound. So some of the properties are there of that of the mixture and compound which differ from each other. When we were talking about the mixture, we have seen here, students, that mixtures are basically divided into two, and that is homogeneous mixture and heterogeneous mixture. Homogeneous mixture, which is having the, you can say that it is having no visible boundaries, it is uniform throughout the mass. It is a homogeneous one, okay? And when we were talking about the homogeneous, so we have seen the solution and the alloys. So solution is also what? It is made up of two components, and when you look at them, they seems to be the homogeneous. It means they are uniformly present throughout the mass. So it seems that okay, it may be a compound, but actually the property which is possessed by that of the solutions are the properties of that of the mixture. That is totally different from that of the compound. The same thing happened with that of the alloy, that it cannot be separated by that of the physical means, which is a property of a compound. But the other property which is possessed by that of the compound is totally different by that of the properties which is possessed by the alloys. Okay, so which makes the alloy as a mixture because it is having the property of the mixture. So it seems that both of them are the homogeneous, so maybe compound, but actually when we look at the properties of the alloy and that of the property of the solution, we have seen here that both of them are actually the mixture only. Okay, now let us move forward and see the next topic in this chapter, and that is solution, suspension and colloids. Solution, suspension and colloids. So we will see all these things, their properties and how they differ from each other. So before we go and understand this term, student, we should know here two things, and that is solute and solvent. Okay. So when we talk about the solute is what? It is a substance which get dissolved into the another, that is known as solid. Or we can say whose amount is lesser than the other one, that is known as a solute. Another term which is here is known as solvent. So solvent is that substance in which this solute get dissolved. Or we can say that it is a substance which is larger in amount. So this one is larger, this one is smaller, and this one get dissolved in the solvent. Okay, so we can write the definition here. The substance which get dissolved into a liquid also, you can say, into solvent I am writing here. Because solvent can, it is not compulsory that it is always a liquid. It can be solid, it can be gas also. And solvent, it is in which solute is added or dissolved. We can also say that solvent is larger in amount, while solute is smaller in amount. Okay, so solvent is larger one and solute is the smaller one. Now, when we were talking about the solute, so most probably we use that solute, it can be a liquid, it can be a solid, or a gas. And if we talk about the solvent, so solvent can also be a solid, a liquid, or a gas. It can be anything, okay? But the thing which varies here, that solvent is in more in number, more in amount, and solute is in less in amount. We will discuss that how a solute can be solid, liquid, or gas, and how a solvent can be a solid, liquid, and gas. Most of the time, till now, we had studied that solute is always a solid and solvent is a liquid, but it is not always like that, students. Okay, so most probably we are knowing that the solvent is what? It is a water or it is a liquid in which we used to dissolve the solute. And solute is what? It is the solid thing which is dissolved in the water. But actually it is not like that. We can say it get dissolved in the solvent, that is solute, and the substance which allow the other substance to be dissolved easily, that is known as the solvent. Now let us see another thing. That is solution suspension colloids. One is a aqueous solution, then a non-aqueous solution. Aqueous solution and a non-aqueous solution. Aqueous, actually the term aqueous is come from a word that is aqua, and aqua means water. Okay, so we can say that here aqueous solution is that in which the solvent is a water. Okay. So, or we can say the solution in which solute is added in the water. Okay, the solution in which solute is added in the water, that is known as the aqueous solution. Non-aqueous solution, students, other than that of the water. So is any other liquid is there which used to dissolve? Yes, alcohol is there, students. This is solvent is benzene is other than water. Other than water. Now see, like alcohol, carbon disulfide, carbon tetrachloride, acetone, etc. Okay, so the solvent which is other than water, that is known as the non-aqueous solution. So we can also write it like, that is the solution in which solute is added other than water. Okay, is added, you can say, in the liquid which is other than water. Okay, so this was about that of the aqueous solution and that of the non-aqueous solution, students. Now let us move forward and try to understand the thing, and that is the first one, which is known as the solution. So you can make any of the solution, students, that either it can be a sugar or a salt or a copper sulfate. You will always find there two components. First one is the solute, then solvent. And this solute and solvent combine to form solution. Okay. So solution is a homogeneous mixture. Okay. It is a homogeneous mixture. Mixture of two or more substances. So right now we had also discussed about that. The solution is a homogeneous mixture. Okay. Example, students. Lot are there. Sugar, solution, salt, water, copper sulfate, copper sulfate solution is there. Then vinegar, then metal alloys is also kind of a solution, metal alloys, etc. These all are what example of that of the solution in which two or more substances they combine together to form a homogeneous mixture. Okay, so when you look, if you take an example of anything like that of the sugar solution or a salt solution, why we are taking this? Because it is a very common thing that you can observe at your home also. So, if suppose you have taken salt or sugar and dissolved in water, so you first of all the thing which you have seen here, that is, it is a homogeneous mixture. It means it will remain present throughout the mass. Right? So, I already had discussed about, let me remind you once again, that if suppose you will take a 1 teaspoonful of water in which the sugar is dissolved or in which the salt is dissolved, you will find that from wherever you are taking this sugar solution, it means from whichever part of the glass, you will always find the taste of the sugar or the salt, whatever you have added in it. So it is homogeneous. It means that solute particle is properly mixed into that of the solution, into that of the water. So we will see that it is a homogeneous mixture. The second thing, are you able to tell that okay, this is the particle of a sugar, this is the particle of the salt? No. Why is it so? Because they are very small and they cannot be visible through our naked eye. So looking at that, we cannot say that where is the particle of the salt or that of the sugar. So we will say that the particle size is very small. Okay, so we can say that this is the sugar solution or that of the salt solution. Now, when you look at the copper sulfate solution, so there also we used to add the copper sulfate in that of the water, in the distilled water, and we make the solution of the copper sulfate solution, students. What you will find that there also the property will remains the same. It means there also the copper sulfate is properly mixed. It is a homogeneous mixture and you cannot see and tell that where is the copper sulfate particle is actually present, because it is present throughout the mass. So it is a true solution which is blue in color. Here it is colorless, but it is blue in color. So we do not have to look at the color, but we have to see that whether it is following the properties or not. Now let me tell you a few more properties of that of the solution. Now you have taken the sugar solution and you have seen that whether the particles are visible or not. You will find that no, it is not visible. We cannot see through our naked eyes. Now, even if you look with the ordinary microscope, also student, you will be not able to find the particles of the sugar or that of the salt. Now, not only this, student, if you have taken the salt solution or you have taken the sugar solution, now if you try to filter it with the help of the filter paper, what will happen? You will find that nothing will going to stay on that of the filter paper. So when you try to filter it by keeping the filter paper in the funnel and when you try to filter it from one beaker to the other, you will find that nothing will going to remain present in the filter paper. It means no residue will be formed by that of the true solution. So it is not possible to separate the true solution with the help of the separating technique, and that is known as a filtration method. So we are not able to separate it with the help of the filter paper or a filtration method. Okay. Now, this is another property. Then, now the next thing what you have done here, student, that you have taken this sugar or the salt solution and you had kept it. After dissolving, you had kept that of the glass on a table and left it for a few minutes. Then, even then, after a few hours, when you will look at that, did you find anything at the bottom of the beaker? No. It means they will not get settled down. It means the sugar or the salt particle which is dissolved in that of the water, it will not going to settle down even though if you left it undisturbed for some time. So they cannot be separated through the process of the sedimentation. Okay, so settling of the particle does not occur in case of the true solution. Now, the next one that we can see here, that if suppose you have taken any of the solution, true solution, and you have the flash a beam of a light through that of the solution. Did you find anything? So you will say, no, we do not. Why is it so? Because the particles are very minute and due to which they do not scatter the light. Now you see here, student. Normally, scattering when happen when there is an object, okay, when there is a particle present. So that particle used to scatter the light in a different direction. But since the particle size is very minute, so it is not possible for that of the particles of the true solution to scatter it. And if there will be no scattering, the part will be not visible. You know that we are able to see the things which is present around us because of the scattering only. Okay, so scattering of the particle will not going to occur in case of that of the true solution. So these are some of the properties of the true solution, which is very important. So whenever the question is asked, you will write the properties, as well as if the question is with the help of the example, so you can take any of the example and explain. Let me write the properties of the true solution. Properties of true solution. So the first property of the solution is, students, as we have seen that the solution is a homogeneous mixture. It is uniform throughout the mass. So it means it is next one, the size of the particle is very small. Extremely small, student. Particles are extremely small. They are extremely small. Even it is less than a 1 nanometer in diameter. Okay? Extremely small. It is less than a 1 nanometer in diameter. Okay, so size of the particles are extremely small and it is even less than the 1 nanometer in diameter. So if it is a very much small, student, so we are not able to see it. Even it is this much small that we cannot see it with the help of a microscope. So we can write it, that is the size of the particles are this much small that it cannot be seen even with the help of a microscope. Okay, so even we cannot see it with the help of a microscope. Okay, next property is that if you try to filter it with the help of a filter paper, it will not going to filtered. Means no residue will be formed in case of a true solution. So the particles can pass through the filter paper. The particles of the true solution can even pass through a filter paper. Okay, it means no residue is formed. No residue is formed. These are a very important point of that of the solution. Then the next one is solution are very stable. The solution very stable. Okay, stable, it means the particles do not get settled down. Even after keeping it undisturbed. Keeping it undisturbed. Okay, it means no settling of the particle will occur. Okay, so no settling of particles occur. No settling of the particle occur. Last one, when you pass a beam of a light through it, no scattering of the particle occur. So, a true solution does not scatter light. Okay, it does not scatter light. And the reason is, it is because the particles are very, very minute. Okay, because the particles are very, very minute. Okay, the particles are very, very minute, and due to which it is not possible that scattering of the light can take place in case of that of the true solution. So these are some of the properties of the true solution, which is very important, student, because most of the time in exam the true solution properties asked. If the question is asked that explain the property with the help of an example, you can take any of the example, either sugar, salt, copper sulfate, any of the example, and you will explain with the help of all these properties. Okay. Now, if we talk about the solution, there are a type of a solution also. Okay. And it totally depends upon the type of a solute and type of the solvent. So we can write it, that is types of solution. Types of solution. Types of solution. So I told you about that whenever we talk about the solution, actually what is the solution? Here a solute dissolve in that of the solvent to form the solution. So solute and solvent, both of them together, they form that of the solution. So most of the time we think that solute is always a solid and solvent is always a liquid. Okay. So, but it is not like that. So on the basis of that, it is divided into, that is, solution of solid in liquid. Okay. First of all, solid in solid. Then the second one is solid in liquid. Solid in liquid. Then liquid in liquid. Liquid in liquid. Then gas in liquid. And finally gas in gas. So you can see that these all can be the solution. Okay.